Intersection of straight lines, example 2. The line 3x minus 7y equals negative 25 passes through the point A, 8, 7. And we could easily check that that works. 3 8s are 24, take away 7 7s are 49, that does give us negative 25. So this is true. And the line 7x plus 3y equals 19 passes through the point 4, negative 3. The lines meet at the point C. Find the exact area of the triangle ABC. So I would like to draw a sketch of this. So if I put A here at 8, 7, and B is at 4, negative 3, so we'll put that down here somewhere. Now, the gradient of this one, if we just rearrange a little bit, so put the 7y on the other side and divide by 7, the gradient of that one would be 3 sevenths. So that's actually going to go upwards. It's not going to go down there. It's going to go upwards a little bit like this. And then this one here, if we rearranged, would have a gradient of negative 7/3. So that would come upwards like this. So they're going to meet at this point here, which is C. And then we're going to form a triangle, and we want the area of that triangle. So let's see whereabouts they meet. So 7x plus 3y is equal to 19. Let's call that equation 1. And 3x minus 7y is negative 25. Let's call that equation 2. So if I do equation 1 and I multiply that by 7, that gives me 49x plus 21y. And I think I'm going to use the calculator here. So let's just grab my calculator. Bring it in here. And I've got 7 times 19 to do. It's 133. So 133. And I'll do equation 2 and I'll multiply that by 3. So that gives me 9x take away 21y is equal to negative 75. Let's call these 3 and 4. And I've got a plus 21y here and minus 21y here, so I can add the two equations. So that's 58x is equal to, and let's just grab the calc again. And if I'm adding those, I've got 133 take away 75, and that gives me 58, which is quite nice. And therefore x is equal to 1. If we sub into equation 1, then I've got 7 plus 3y equals 19. Gives me 3y equals 12. So y equals 4. And that tells me that C is the point 1, 4. So we have the 3 points, but of course we don't have a formula that helps us work out the area of a triangle just given 3 points. So there must be some other feature that's nice about this. Well, if we look at 3x take away 7y is negative 25, and we rearrange that, so 7y is going to be 3x plus 25, and then y is 3/7 x plus 25. Now I sort of did that at the beginning when I was doing my sketch, just to find the gradient of 3/7 that went up this way. And then we've got the 7x plus 3y is 19. So 3y is negative 7x plus 19, and therefore y is going to be negative 7 over 3x plus 19 over 3. And what you should notice here is that 3/7 multiplied by negative 7/3 is equal to negative 1. And that tells us this is a right angle just here. So I can use this side as the base and this as the height of a right angle triangle, and I can just use the formula half times base times height. So we've got half multiplied by the base. But what is the base? It's the distance between these 2 points. What I can do is just form a right angle triangle here and use Pythagoras. So x coordinate 1, x coordinate 4, that's 3 across. Y coordinate 4, y coordinate negative 3, that's down by 7. So that's going to be the square root of 3 squared plus 7 squared. So that's going to be the square root of 9 plus 49, which is 58. And then we'll do the same with these 2 points. So if we form a right angle triangle just here, so x coordinate 1, x coordinate 8, so that's 7 across, and then the y coordinates going from 4 to 7, that's 3. So that's also the same size triangle. So that's also going to be 58. So root 58 times root 58 is 58. So we want half of 58, which is 29. So we've got 29 square units.